Hello and welcome. In this video we want to use L'Hopital's rule to prove that limit of e to the x over x to the n when x approaches infinity equals infinity, which in this relation n can be any positive integer number. For example, n can be 1, 2, 5, 10 and so on. And by proving this, that limit of e to the x over x to any power, even e to the x over x to the power of 1000, this limit equals infinity. By proving this, we show that the exponential functions, e to the x is an exponential function. We show that exponential functions approach infinity faster than any power of x. So e to the x grows faster than x to the 100, x to the 2, x to the 1 billion. And this is important for our understanding of functions. E to the x grows very, very fast compared to polynomials in general. So we want to prove that limit of e to the x over x to the n as x approaches infinity is infinite. Because the limit is in the fraction form and the limit is basically infinity over infinity. If you substitute infinity, or not really substitute, when x approaches infinity, e to the x approaches infinity and x to the n approaches infinity, so the limit is infinity over infinity, and we can use L'Hopital's rule for finding this limit. By applying L'Hopital rule, we want to find the derivative of numerator and denominator separately. This is how L'Hopital's rule works. We take derivative of numerator, it is e to the x. Derivative of x to the n by power rule is simply n x to the n minus 1. Again, we have a limit in the fraction form. And if we suppose still we have x to a power, it's infinity over infinity. So we can apply L'Hopital rule again. Derivative of e to the x is again e to the x, and derivative of denominator is n times n minus 1 x to the power of n minus 2 as x approaches infinity. And we can continue applying L'Hopital rule up to the point that power of x equals 0, which means that x goes away and only we have coefficients here, the constants here. For example, for a moment, suppose x to the n is basically, for example, x to the 3. In this case, if we apply L'Hopital rule 3 times, first time it would be 3x to the 2, then 6x, and finally only 6 remains. Here we stop because there is no x in denominator here. If it is x to the 5, you have to apply L'Hopital's rule 5 times. If it is x to the 2, you have to apply L'Hopital's rule 2 times to get rid of x to the n from the denominator. Now let's back to our question here. So by applying L'Hopital's rule repeatedly, and actually n times in total, we get to here. Limit e to the x in numerator, and the denominator would be n times n minus 1 times n minus 2 and so on up to 1 when x approaches infinity. So by applying repeatedly L'Hopital's rule, the degree of x becomes smaller and smaller, and finally we can get rid of x to the n and only these numbers remain in the denominator. And probably you know that n times n minus 1 times n minus 2 so on up to 1 is n factorial. So briefly you can rewrite this as n factorial if you want, but let's leave it like this. Now here we cannot apply L'Hopital's rule anymore because x goes to infinity, and this makes numerator approach infinity because x is here and e to the infinity is infinity. But in denominator we don't have any x, it's only n, and n is a constant. Remember, for example, n is 3, n is 5. So if, for example, n is 5, in denominator here we have 5 times 4 times 3 times 2 times 1. It's just a numbers. And if you multiply 5 by 4 by 3 by 2 by 1, it would be 120. 120. It's not infinity. So this limit is not anymore infinity over infinity. So makes no sense. And we are not allowed to use L'Hopital's rule anymore. Now, when x approaches infinity, numerator is infinity, denominator is a number. So infinity over a number is infinity. And this completes the solution of this question. So limit of e to the x over x to the n when x approaches infinity equals infinity.